Quadrilateral?
Yeah, quadrilateral, correct. So a polygon is a plane shape, right? Plane meaning two-dimensional, right? Plane or flat shape, that's a two-dimensional shape. All right, so it's a plane or flat or two-dimensional figure bounded by straight lines or bounded by straight sides. This is the definition of a polygon, right? And the simplest polygon is a triangle, right? So a polygon with, so let's say the number of sides and let's name them, right? So number of sides and then the name. So then if you have, hold on, I just want to draw kind of like a table, right? So a three-sided polygon is a triangle. So three sides, it's a triangle. Four sides, as Soraya rightfully said, is a quadrilateral. And Zara named two quadrilaterals there, a square and a rectangle. What about a five-sided polygon? Anybody knows what that's called? A five-sided polygon.
Miss a pentagon?
That's right. A pentagon is a five-sided shape, a five-sided polygon. Yes, Faith. What about six?
Hexagon?
Hexagon is correct. A hexagon is a six-sided polygon. What about seven? Anybody knows for seven?
Septagon?
Septagon. And then eight is octagon, right? Eight is octagon. Nine is nonagon. 10 is decagon. So the prefix tells us the number of sides. So the prefix tri is 3. Quad is 4. Pent is 5. Hex is 6. Sept is 7. And oct is 8. So these are some of the, well, these are the first eight of them. These are their special names. They are triangle, quadrilateral, pentagon, hexagon, septagon, octagon, right? Now, you also have regular polygons and irregular polygons. Anybody knows what's the difference between a regular polygon and an irregular polygon?
Regular polygon has all equal sides.
Mm-hmm. Correct. Right? So regular polygons have all equal sides, and once a shape has all equal sides, it also means that all of their angles are equal, right? So a regular polygon has equal sides, whereas an irregular polygon does not. So regular polygons have equal sides, right? So all sides are equal, all equal sides, and all equal angles, whereas irregular polygons, they do not have equal sides, so no equal sides, or not, we should say not all sides are equal, because it could probably have two equal sides, right? Or like some equal sides, and then some of them are not equal. So not all sides are equal. And clearly, if not, well, it follows that if not all the sides are equal, then not all the angles are equal either. Right? So, for example, a regular triangle, right? A regular triangle would be what type of triangle would be a regular triangle? Well, which type of triangle, sorry, I should ask that question better. Which type of triangle will be considered a regular polygon? Because you know there are different types of triangles, right?
Equilateral.
That's right. So, an example of a regular three-sided polygon would be an equilateral triangle. That's correct. An equilateral triangle. And what about irregular three-sided polygon. What type of triangle would that be?
Isosceles
Yeah, isosceles.
or
What else?
scalene?
Scalene, that's right. Correct. So it could be a scalene or even an isosceles, right? So it could be a scalene or even an isosceles triangle. So those two would be um, irregular three-sided polygons, which are definitely triangles, right? Any three-sided flat shape is a triangle. What about a quadrilateral? Which one would be regular?
Four-side?
What's that, honey?
Four-side polygon?
Four sides. I know which side of a quadrilateral has four sides, yes. But which of those quadrilaterals would be considered regular polygons?
A square?
A square. What about a rhombus?
That too, miss.
Yeah, right. Well, what about irregular quadrilateral? Which one would be like a irregular?
Triangle.
Mm, a rectangle.
Parallelogram.
I meant yeah, correct, a parallelogram as well, right? So those are some irregular polygons. And also like you could have a regular hexagon, which would be a four-sided a six-sided shape that has all equal sides, but you could also have an irregular hexagon, right? So all of the polygons can be regular or irregular. So far, so good?
Yes, miss.
Guys? Yeah, okay, cool. So let's look at the interior and exterior angles in a polygon, right? So as its name suggests, the interior angles in a polygon are the angles inside of the polygon. So the angles bounded by the sides of the polygon will be the interior angles of the polygon. So like uh these are all interior angles, right? So these are interior angles in the polygon because they are inside, right? So these are the angles that are enclosed in the shape. Angles that are enclosed in the shape are interior angles. Right? And just like how you have interior angles, you can also have exterior angles. So let me show you what that would look like. The exterior angles, let's say I have a polygon, and this is a irregular one. It's just a random one that I'm drawing here. Right. Good. So this polygon is a quadrilateral because it has four sides, right? So this is a quadrilateral. But the exterior angle on this quadrilateral is going to be the angle formed when you extend one of the sides. So this angle here, right? This is an exterior angle. So it is formed when you extend one side of the polygon. So this here is an exterior angle, and an exterior angle is formed when you extend one of the sides of the polygon. So this is the exterior angle formed when one side of the polygon is extended. And it could be any side, okay? It could be any side of the polygon that I choose to extend, and that would be the exterior angle. So like for instance, if I were to extend this side like this, for instance, then this angle will be the exterior angle. Or if I extended it here, then this angle would be the exterior angle. See? So those are exterior angles. All right, so let's talk a little bit about the sum of the interior angles in a polygon. The sum of the interior angles. Now you would know some of them actually. What is the sum of the interior angles in a triangle?
180.
Yes, right? So the sum of the interior angles in a polygon. What about a quadrilateral? How many degrees does a does a quadrilateral have?
360.
360, right? So what about a pentagon? Do you know? Anybody knows how many what is the sum of the interior angles in a pentagon?
540.
Yes. So the sum of the interior angles in, well, a triangle is equal to, in a triangle equals 180 degrees. In a quadrilateral, it is 360 degrees. And as that was Zara, right?
Yeah.
Zara said it's 540 degrees in a pentagon, which is a five-sided polygon. There's a formula that we can use to calculate the sum of the interior angles in a polygon. And for some reason, I always forget what it is. But let me see if I could remember it by using it in these three, right? If not, I'll just Google it. But I think it is the sum of the interior angles in a polygon with n sides, meaning n is the number of sides, is found by saying n minus 2 multiplied by 180 degrees. I think this is the formula. All right. To test if this formula is correct, I'm going to check it for each of these. So like a triangle, for example, a triangle has three sides, right? So n in this case is equal to 3. And let's see if that works out with the formula. Well, that would be 3 take away 2 multiplied by 180, which is 1 times 180, which is 180. So it works there, right? In a quadrilateral, n is equal to 4. So then it'll be 4 take away 2 times 180, which is 4 take away 2 is 2, and 2 times 180 is 360. So it works here as well. And then in a pentagon, n, the number of sides is 5. So that would be 5 take away 2 times 180, which is 3 times 180. And that is actually 540. So that's the formula. Huh. Most times I forget it, guys. Like I always forget the formula for the sum of the interior angles in the polygon, but it's something that you do have to remember. I've seen questions with it in CSEC, right? So the formula to calculate the sum of the interior angles in any polygon is the number of sides minus 2 multiplied by 180 degrees. So let's say I wanted to find, so an example would be, let's say I wanted to find the sum of the interior angles in a polygon with 10 sides. So a polygon that has 10 sides. Well, if the polygon has 10 sides, recall the formula. Let us recall the formula is n minus 2 multiplied by 180 degrees, right? So if this polygon has 10 sides in this question, it means that n is equal to 10. So therefore, applying it in the formula, it would be 10 minus 2. So that'll be 10 minus 2 multiplied by 180 degrees. 10 minus 2 is 8. So 8 times 180 degrees is equal to, let me see, 180 times 8 is 1,440 degrees. So the sum of the interior angles in a polygon with 10 sides will be 1,440 degrees. And if I wanted to find out what is the size of each angle in the polygon, I would say 1440 divided by, if it's a regular polygon, right? If it's a regular polygon, it would mean that all 10 angles are equal, right? So if it's a regular polygon and I want to find out what's the measure of each of the angles, I will simply divide 1440 by 10, and that would give me the the size or the magnitude of each angle in the polygon. So another interesting thing, well, let's look at the question. Um, Before I give you that, let me just tell you the sum of the exterior angles of any polygon, regardless of the number of sides that it has, is 360 degrees, right? So that's a fact. A fact for you to remember is that the sum of the exterior angles, the sum of the exterior angles. I'm going to send you these notes afterwards, so please write them down, or print it, whatever you want to do, right? So the sum of the exterior angles in any polygon is actually equal to 360 degrees, right? All right, so let's look at the question that has nothing to do with this fact. So let's draw, I'm going to draw a polygon and we're going to figure out the size of the angles. Okay, so let's say it's a triangle. So I'm going to draw this. Give me a second. When you're drawing your shapes, please use a ruler. Good. Perfect. And this is not drawn to scale, okay? So everything is not perfect. Okay, good. All right. And then let's say we have this angle here is 80 degrees. This angle is X, and this angle is Q. Um, this angle is 45 degrees. This angle is R on the outside here, and this angle is P. So I want to find the size of each angle here. So guys, how would I find the angle X? Anybody have a clue about how I might find the angle X in this one?
Isn't x equal to, wait, no, mind, sorry.
So this is triangle ABC. It's a triangle and then I have the exterior angles added onto it. So if I know that this angle inside the triangle is 80 degrees and this one is 45 degrees, can I find the third angle in the triangle?
Yeah,
How would we do it?
80 plus 45 minus 1
Hmm.
is that?
That's right. How come?
Because the interior angles of a triangle add up to 1 is that?
That's right. Wonderful. So the angles within the triangle adds up to 180 degrees. So x plus 80 plus 45 is equal to 180 degrees. So therefore, x plus, I think this will be 125. 80 plus 45 is 125, would be equal to 180. And so x will be equal to 180 take away 125. And that would make x equal to 55 degrees,
55.
I think. 55, honey?
Yeah.
Good. So x is 55 degrees. Okay. What about what about P, Q, and R? What about the angles on a straight line, guys? Sorry,
And
excuse me.
straight line is also 1 is that?
That's right. The angles on a straight line add up to 180 degrees. So that means that 45 plus R is 180 degrees. 80 plus P is 180 degrees, and X plus Q is 180 degrees. And so I could find what R is by simply saying 180 take away 45, right? So R would be equal to 180 take away 45, which gives me, what is 180 take away?
135.
Yeah, so R is 135 degrees. P would be equal to 180 take away 80 degrees, which is 100. So P is 100 degrees. And finally, Q would be equal to 180 take away 55, which is 125. 180 take away 55, which is 125 degrees. And now I have found all the angles. I'm just going to put them in, right? So X is 55 degrees because X and 80 and 45 are the three angles within a triangle, right? P is 100 degrees because P and 80 degrees are on a straight line, which means that they add up to 180. 45 and R are also on a straight line, so that makes R equal to 135 degrees. And finally, X and Q on a straight line, which makes Q 180 take away 55, which is 125 degrees. I just want to put X in a different color. So let's put X in pink. X is 55 degrees. So as you can see, girls, and boys, sorry, Matthias, forgot you were here. The exterior angles here are 100, 135, and 125. And by this fact up here, that the sum of the exterior angles add up to 360, these three should add up to 360. So 125 plus 135 plus 100 is actually equal to 360 degrees, right? So it works. This is how you would use your knowledge, not just of what we just learned about a polygon, but of angles in general. Because all you needed, like you didn't need to know this fact that the sum of the exterior angles add up to 360 degrees. All you needed to be able to figure out the different sides, the different angles, sorry, in this shape, was the fact that the interior angles in a triangle adds up to 180, as well as angles on a straight line adds up to 135 degrees. Right? So important information there. All right. Guys, I have to end class now, but I am going to send you guys an exercise with some questions to find the missing angle. And I'd like you all to complete it in the next 30 minutes and send it to me, please. Take a picture. Please draw the shapes. I'm going to send it to you now, and I would like you to send it to me by 6 o'clock. Is that clear, guys?